These notes are about what the discriminant can tell us about a quadratic equation. First of all, we need to recall that if we have a quadratic equation in the form ax squared plus bx plus c equals 0, then we actually know our solutions given by the quadratic formula, negative b plus or minus the square root of the quantity b squared minus 4ac all over 2a. We've figured out that when we're solving quadratic equations, sometimes there's two solutions, sometimes there's only one solution, and sometimes there are no real solutions. So what we can figure out is, which type of equation we have before we even start. And we look at something called the discriminant. The discriminant is the part of the quadratic equation, the part of the quadratic formula that's under the radical. So the discriminant is b squared minus 4ac. It should make sense that this is the expression that tells us how many and what type of solutions we have. Notice, since it's under the radical, if this whole expression was negative, then we would have a non-real number as our solution. If it is 0, we can, investigate what happens, and if it's positive, we can investigate what happens. But overall, this discriminant will tell us how many and what type of solution. How many solutions and of what type? So by type, I know that maybe we're talking about some real solutions, maybe we're talking about some rational solutions, maybe some irrational solutions. So let's investigate the three cases. We know that it can either be negative, it can either be 0, or it could be positive. So let's take a look first at what happens if b squared minus 4ac is negative. Here's a quadratic equation, 3x squared minus 2x plus 1. Let's find our discriminant. B squared minus 4ac is the quantity negative 2 squared minus 4 times 3 times 1. And that gives us 4 minus 12, which is negative 8. Our discriminant is negative, which means we're going to end up with a negative 8 underneath the radical if we try to use the quadratic formula. So I know that there are no real solutions to this quadratic equation. We do have something called complex solutions, but we haven't yet talked about that number set. So for now, we can say that this quadratic equation has no real solutions. Additionally, I know something about this function. 3x squared minus 2x plus 1, since we were essentially trying to find the zeros of that function from our red equation up at the top, and there were no real solutions to that equation, then I know that this function never crossed the x-axis. It has no x-intercepts. So if the discriminant of our quadratic equation was negative, then the related function, the related quadratic, if I was to graph that, I know that it would never cross the x-axis. So it might look something like this. Something like that. I know it has a y-intercept of 1, so that's probably a pretty bad sketch. I don't know what my scale is, but I just wanted to sketch something that had no x-intercepts. And we know that right away before we even start trying to graph it or trying to start solving, because we figured out what the discriminant was first. Now, let's investigate what happens if our discriminant, b squared minus 4ac, equals 0. Let's just verify that first. b squared minus 4ac, in this case, is 16 minus 16, which is indeed 0. Think about what that means in our quadratic formula. We now have x equals negative b plus or minus the square root of b squared over 4ac, which in this case is 0, all over 2a. What is the square root of 0? That's just 0. So this becomes just negative b over 2a. That should sound familiar. That's the x-coordinate of our vertex. If we're in standard form, that was one of the methods to find the vertex. So wait a second. You're telling me that if the discriminant is 0, then the solutions to that quadratic equation is really the vertex? Well, yes, that would mean that the vertex is also representing a 0 of that function. So that means, if you imagine that, a graph of that, if the vertex is also an x-intercept, that means our parabola is just sitting on the x-axis. So something like this. We only had one solution, and it was right here, and it also is the vertex. And we knew that by calculating the discriminant and realized, wait a second, the discriminant was 0, so we also only have one solution. It's just where that vertex is touching the x-axis. Let's figure out if we can actually solve this equation, maybe not by using the quadratic formula. We can actually solve this by factoring. I'm going to take out a negative 2. We're left with x squared minus 2x plus 1 equals 0. And I can continue to factor negative 2 times the quantity x minus 1 squared equals 0. Notice this is a parabola with vertex 1, 0 that opens down. And it should make sense that the solutions are also 1 and 1. If we write this out fully, this is x minus 1 times x minus 1 equals 0. So our two solutions are x equals 1 and just x equals 1 again. I don't need to write it twice. So we can really see how when our discriminant is 0, we end up with just one single solution, and that solution happened to also be represented by the vertex of that graph. So we can also say that it only had one x-intercept. Let's look at one example where our discriminant is positive. B squared minus 4ac is 9 plus 20 in this case, which is 29. Well, if we think about the quadratic formula, that means that we had a root 29 somewhere in our solution. That would mean that we are going to get two real solutions. Ooh. Solutions, there we go. You know, we would get negative b plus root 29 over 2a and negative b minus root 29 over 2a if I wanted to continue to plug in. Notice those solutions aren't super nice. Let's see. Let's actually figure out what that would be. Negative b plus or minus the square root of 29 all over 2 times 1, which is 2. I can't simplify this. I know that if I graphed f of x equals x squared plus 3x minus 5, it would have two x-intercepts. That's what that would mean graphically. And I know where they are, negative 3 plus root 29 over 2 and negative 3 minus root 29 over 2. So that might look something, I don't know, like this. I just know it's going to cross the x-axis twice. And neither of them are nice values. We have negative 3. The root 29 tells us that they're real, but not the greatest numbers. Let's look at one more example of if our discriminant is positive. Notice, now we have our discriminant is positive and something else. Let's see what our discriminant is. B squared minus 4ac is 36 minus 20, which is 16. So it's positive, so I know we're going to have two real solutions, but let's actually find them. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. We're not done in this case because root 16 is very easily simplified. Root 16 is just 4. So our two solutions were negative 6 plus 4 over 2, which would be negative 1, and negative 6 minus 4 over 2, which would be negative 5. Negative 6 minus 4, negative 10 over 2 is negative 5. So it turned out that if our discriminant is positive and a nice number like 16, we get two really nice solutions. Now, this nice number like 16, what that really is a perfect square. A perfect square. So if our discriminant is not only positive, but also a perfect square, then we have two real rational solutions. If that number was not a perfect square, like in our previous example, then we had two real irrational solutions. What's nice about realizing that we have two rational solutions here is that tells us something. That means we could have probably factored instead of using quadratic formula. And if you investigate this, if you look closely, you'll realize, wait a second, it was very silly to try to use quadratic formula here, because I can factor this into x plus 5, x plus 1 equals 0 very easily. And I could have solved it a lot faster than having to worry about plugging into the quadratic formula. And of course, we can see our two solutions quickly, -1 and -5. So to summarize, if b squared minus 4ac, if our discriminant is negative, then we have no real solutions to our related quadratic equation. If it is 0, we only had one solution, and it's going to be rational. It's going to be a kind of nice number. We're not going to get square root of 7 or something in there. One rational solution. If b squared minus 4ac is positive and a non-perfect square, we will get two irrational solutions. If it is positive and a perfect square, we will get two rational solutions. If you have a non-perfect square, that means we couldn't have factored our original quadratic, so we need to use quadratic formula. So we'd probably want to use quadratic formula if our discriminant was positive and not a perfect square. We also might need to use quadratic formula if we have a negative discriminant. But again, those are the kind that we're going to talk more about later because we're not even sure what to do with non-real solutions. However, if your discriminant is 0 or positive perfect square, do not use the quadratic formula. That means you could have factored it, which is usually a lot faster, a lot easier. And I mentioned before that, of course, you can use quadratic formula, but there's so much more room for error there. So just be very, very careful. I highly recommend you calculate your discriminant before you do anything, and then make an informed decision about how to go about solving your quadratic equation. Good luck!